Welcome to the Deep Dive. This is where we take those huge research reports, piles of data, and boil them down into something you can actually use, high-impact insight. Today, we're looking at what two of the real giants in generative AI, OpenAI and Anthropic, have found out about how their tools are actually being used. Out there in the wild, we've got some really fresh sources packed with new data. It covers everything, really, from broad consumer habits right down to these super specific enterprise API usage patterns just over the last few months. Our mission today, it's pretty focused. We're digging into the hidden implications, and sometimes they even seem to contradict each other, of this AI adoption wave, specifically for enterprise data strategy. Think of this deep dive as your shortcut. It's about understanding why data engineering isn't just changing a bit, it's fundamentally transforming into something much more strategic.
Yeah, it's a really fascinating moment we're in. And these sources, they clearly show two kind of separate worlds emerging. Researchers are actually calling them dual trajectories for AI adoption. So one path is huge, broad, consumer-focused, think ChatGPT for everyone. The other trajectory, that's much tighter, more specialized, and really centered on the enterprise. And if you look at the OpenAI analysis first, the numbers are just staggering. 2.5 billion daily interactions, 700 million weekly users. It's huge. This story there for consumers, it's definitely one of democratization. It's getting easier to access, easier to use, and it's measurably expanding what, the average person can do.
Right. And that democratization point, the data they shared is pretty striking, isn't it? They mentioned reducing the gender usage gap in certain fields, went from like 80% masculine down to just 48%. That really suggests that access to these powerful tools is genuinely broadening out to the general public.
It absolutely is, no question. But then you pivot. You look at that second trajectory. Anthropic's economic index, it tracks 8 months of really intensive enterprise API usage. And the story completely flips. Instead of democratization, all the data points towards a concentration of competitive advantage. Businesses using it strategically, not just generally.
Okay, so that's the tension, right? The tools are out there, they're powerful, they're widely available, but the actual business benefits aren't spreading out evenly. So if consumers are adopting broadly, what's the main thing defining that corporate path? What points to this concentration of advantage?
It's baked right into how businesses are using it. The really striking revelation from Anthropic, and honestly, this should probably worry any data team that's relying on older systems, is that 77% of enterprise API usage follows these rigid, predetermined automation patterns. 77%.
Wow.
Compare that to like 50% on the consumer chat platforms. It's a huge jump.
77. I'm actually surprised it's that high already. Does the research give any clues why? Why so much automation in enterprise compared to, say, creative brainstorming or something?
Well, it seems to be two main drivers. First, the constant push for efficiency, obviously. And second, just the nature of core business processes. They're often very repeatable. Businesses aren't just, using AI to help draft emails. They're plugging it into marketing optimization, financial reconciliation, filtering high volumes of customer messages, internal code reviews. These things demand automation for scale and efficiency. And such a high automation percentage, it means we really have to shift our thinking. We need to stop seeing the AI mainly as an assistant. We need to start viewing it as replacement infrastructure.
Replacement infrastructure, okay.
Yeah, because if 77% of your enterprise AI calls are automated, then every single one of those workflows is now completely, utterly dependent on the quality, the accessibility, the reliability of your underlying data systems. The AI isn't just using the data anymore. It's the main automated consumer of whatever your data infrastructure spits out. That makes the data pipeline, it makes it the most critical point, either for failure or for success.
That completely reframes data architecture, doesn't it? Instantly. Okay, let's shift gears a bit. From inside the company to the global view. This is where it gets really interesting, I think. These studies show a pretty stark divide, geographically and economically, in how sophisticated the AI deployment is.
Yeah, the analysis is remarkably consistent, actually. AI usage intensity lines up directly and strongly with national GDP. The sources found that for every 1% increase in GDP per working age person, there's about a 0.7% increase in Claude usage per person. It's not just a small trend. It seems to be a basic economic reality of AI deployment right now.
And the differences at the extremes are huge. You mentioned Singapore.
Right. Singapore is leading the way, using it 4.6 times more than you'd expect just based on its economic profile alone.
And then countries like Nigeria.
Much lower, registering just 0.2 times the expected usage.
Whoa.
It really suggests the barrier isn't just the AI model itself or even basic internet access. It's something deeper, something foundational in the infrastructure.
Infrastructure meaning data infrastructure.
Exactly. And you can see that reflected in what people are asking the AI to do in different places. In wealthier regions, places with more mature data ecosystems, businesses are using AI across lots of different strategic functions. They're asking it to optimize really complex systems. But then, in countries with lower adoption rates, the usage gets really concentrated on specific localized tasks, especially coding. Over half, more than 50% of Claude usage in India, for instance, is just for coding tasks. And that pattern tells us something important. Data infrastructure maturity directly dictates how sophisticated your AI adoption can be. If you've got weak internal data pipelines, AI gets stuck doing easily contained things like helping with code rather than being deployed for, complex system-wide strategic initiatives.
So the tools are everywhere, but the use isn't. And it sounds like the bottleneck isn't the AI's intelligence, it's internal. The sources call this the context crisis. Can you unpack that a bit? What does that mean for a data team trying to push forward?
It boils down to organizational data readiness. That's the fundamental constraint. Think of it like this. Imagine the AI model is the smartest student in the world, truly brilliant. But your data infrastructure, that's the textbook you hand that student. Now, if that textbook is a mess, disorganized, full of contradictions, no clear structure, no definitions, even the brilliant student is going to struggle, right? They'll either fail or only be able to do very simple things.
Makes sense. The input quality limits the output quality.
Exactly. That is the context crisis. Organizations have to build the data infrastructure that can feed relevant, timely context to the AI systems. And what's fascinating here is the link to cost sensitivity. The research shows that the companies demonstrating weak price sensitivity for AI, the ones willing to pay top dollar for the best models out, they're precisely the ones who've already built this kind of high context data infrastructure. They've essentially solved their context crisis, and that's why they see the value and can justify paying more for the AI itself.
So the ROI is directly tied to the state of the data platform. Okay, drilling down then. What does this actually look like day to day for, say, a data engineer? How are these AI systems using data differently on a practical operational level?
We're seeing operational patterns shift quite dramatically, especially in development workflows. The Claude usage data showed this really interesting swing. Tasks related to debugging and fixing errors, they actually fell by about 2.8 percentage points. But at the same time, tasks focused on creating new code, they more than doubled, up by 4.5 percentage points.
So a net shift of over 7 percentage points.
Yeah, 7.4 point swing overall. And it suggests that the AI's output is becoming more reliable, more deployable straight away, needing less immediate human fixing.
Okay, so what's the immediate operational reaction needed from data teams?
Well, if the AI is writing better code and automating 77% of workflows, our standards for data quality have to go way up, significantly. That old standard of, good enough for a human analyst to look at, that's gone. We need data quality that's robust enough for error reliability. Automated systems are less forgiving of fuzzy data.
And you mentioned that 77% automation figure again. What does monitoring the infrastructure need to look like now? You said expanding monitoring to include AI consumption patterns. What does that practically involve?
It means moving beyond just looking at, say, pipeline latency and data throughput. You need to start monitoring the utility of the data the AI is consuming. So pipeline monitoring now has to include new metrics, things like the latency of context retrieval. How fast can the AI get the right background info? You need to track specific AI failure modes that are linked back to bad data or missing features. You need much better monitoring and versioning of the feature stores that feed these automated models. You're not just monitoring data flow anymore, you're monitoring data intelligence. How effectively is the data enabling the AI?
Right. And strategically, the responsibilities sound like they're ballooning too. It's less about just managing the pipes.
Much less.
And more like becoming curators.
Yeah.
Architects almost, like linguists for the AI, defining the meaning of the data.
That's exactly where the next wave of strategic data investment is heading, those emerging responsibilities. They are things like context curation, actively managing and refining the information fed to the AI. Also, AI-ready data formatting. This often requires totally new pipeline designs, built specifically for how AI consumes information, not just how humans do, and critically, implementing what the sources are calling semantic data layers.
Okay, let's pause on that term, semantic data layer, because it sounds pretty crucial for everything we're discussing. How would you define that for someone listening? What is that architecture?
Right. So a semantic data layer isn't the raw data itself, it's an authoritative knowledge graph or a similar abstraction that you build on top of the raw data. It's the layer that translates all the technical tables, rows, cryptic column IDs into actual business meaning. Things like customer lifetime value, product category, likelihood of churn, real concepts. So when an AI queries the system through this semantic layer, it doesn't just see rows of numbers and text. It sees meaning, definitions, relationships between concepts. That's what enables true contextual understanding rather than just sophisticated pattern matching on raw data. And that's fundamentally how you solve the context crisis we talked about.
Got it. Okay, so this whole situation, it creates this unique pressure cooker for data teams, doesn't it? You've got these two opposing demands hitting the same infrastructure. On one side, you have consumer expectations shaped by things like ChatGPT, wanting advisory, conversational, interactive data experiences. And on the other side, you have the business demanding scalable, automated, 77% plus processes running reliably in the background.
Exactly. And that dual demand means your data infrastructure now has to support what we're calling dual-mode data architecture. This is the second really critical architectural shift implied by the research.
Dual-mode data architecture.
Yeah.
What does that look like in practice? What does it entail?
It means designing systems that can handle two radically different ways of interacting, often simultaneously. You need capabilities for the advisory mode. That requires things like natural language query interfaces, tools for interactive data exploration, and really fast, low-latency responses for a human-in-the-loop conversation. And at the same time, you must support the automation mode. That demands reliable, programmatic access, handling high volumes of data efficiently, and having rigorous automated data quality checks baked in for those delegated processes. Being able to deploy AI successfully in both these modes, that's where sustainable competitive advantage is going to come from.
Right. So the research seems crystal clear on this. Data modernization, getting your data house in order, has really become the primary constraint for getting value out of AI. The focus is shifting away from just picking the best AI model. And that, of course, means big opportunities, but also big risks for data professionals right now.
Yeah.
Career-defining stuff.
Absolutely. On the opportunity side, you're looking at dramatically increased strategic influence. Data teams are moving out of the basement, so to speak. There's more opportunity for cross-functional leadership because data infrastructure is now recognized as this central AI enabler. It's not just an IT cost center anymore. And technical specialization in designing this AI-ready data architecture, that's immediately highly valuable, big demand. But conversely, there's risk. Traditional pipeline management, the routine, repeatable tasks of just moving data from A to B, that's likely going to become rapidly commoditized.
As AI gets better at automating those bits itself.
Precisely. Data professionals, and frankly, entire organizations that cling to those legacy architectures and fail to make this strategic shift. They risk finding their core expertise made obsolete by the very AI systems they might be trying to deploy.
Okay, so for data engineering teams, for leaders listening right now who want to future-proof themselves and their organizations, let's boil this whole deep dive down. What's the action plan? What are the critical strategic shifts coming directly out of this research?
All right, 3 key shifts. First, based on that clear evidence that capability, not just cost, drives AI utilization and value. The first shift is non-negotiable. Prioritize capability over cost in data infrastructure. That weak price sensitivity we talked about. It proves that paying a premium for reliable, high-context data infrastructure actually pays for itself pretty quickly through better AI deployment. So focus your investments on premium platforms. Prioritize things like real-time capabilities. Build in redundancy. Move away from just minimum viable cost solutions for your core data stack.
Okay, capability over cost. Makes sense. What's number 2?
Second, you have to elevate the strategic importance of this work internally. Treat data modernization as the primary strategic initiative, not just some IT overhead project buried in the budget. This means doing explicit audits. Where are our AI readiness gaps? It means developing clear roadmaps specifically for implementing things like that semantic data layer we discussed. And it means prioritizing governance frameworks that actually enable automated AI consumption safely, managing security and lineage rather than just blocking it.
Right, enabling, not just controlling. And the third shift. That ties back to that pressure cooker scenario, right? The human versus the machine demands.
Exactly.
Right.
The third shift is implement dual-mode data architecture. You have to consciously design your systems so they can handle both interaction styles effectively. Both the interactive exploration and collaboration, the advisory mode, and the scalable, fully automated consumption, the automation mode. Building that versatility into the core data stack is really the only sustainable way to capitalize on both the consumer-driven enthusiasm and the corporate efficiency mandates that AI brings. Now, just quickly, we do need to acknowledge a couple of limitations in the sources themselves. As we mentioned, the studies aren't perfectly aligned time-wise. Anthropic's data is a snapshot of 8 months of specific API usage, while OpenAI's covers 3 years of much broader consumer activity. So projecting long-term trends where these two converge is still a little speculative.
Okay.
And also, while we see that strong correlation between AI usage and national wealth, we need to be careful. It doesn't automatically prove that AI causes future economic inequality, even if it correlates with existing wealth. Causation is harder to pin down.
Understood. Good caveats. But despite those limitations, the main takeaway seems pretty unambiguous, doesn't it? AI is fast becoming the main, often automated, interface between core business processes and the underlying data infrastructure. The role of data engineering, it feels like its evolution is kind of done. It's finished its transformation. It's now fundamentally about AI infrastructure enablement.
I think that's exactly right. The future really belongs to the data teams who can make that pivot away from just managing old pipelines towards building flexible, semantic, highly reliable data systems that can genuinely support these multiple modes of AI interaction.
So the evidence strongly suggests that the smartest strategic bet for any company isn't trying to pick the winning AI model or predict exactly how deployment will look in 5 years, but rather it's about building highly flexible, context-rich data systems underneath whatever AI comes along. Which leaves us with a pretty important question for you to think about. If data infrastructure capability truly is now the single biggest competitive moat for getting value out of AI, how quickly can your enterprise realistically shift its focus away from just traditional cost optimization in the data stack towards building systems designed purely for adaptability and delivering that crucial context?
That's really the defining challenge, I think, for the next few years. Definitely something to mull over as you look at your own data roadmap. Thanks for tuning in to The Deep Dive.